Which of these molecules has 19 valence electrons? Molecule A, molecule B, C, or none of them? And what does that say about valence electron counts in general? The key to determining valence electrons in each of these Lewis structures is in the sticks and dots that compose them. The first molecule has 7 sticks and 4 dots. The second molecule has 6 sticks and 8 dots, and the last one has 4 sticks and 10 dots. But does that mean that we have 11, 14, and 14 valence electrons respectively? After all, 7 plus 4 is 11, etc., etc. Well, no, because a stick is 2 valence electrons and a dot is 1. So 7 sticks carry 14 valence electrons and 4 dots carry 4. So you add that together, 14 plus 4 equals 18 valence electrons for this molecule. So we'll cross out molecule A because it does not have 19 valence electrons. It's one shy for what we're looking for. We know the second molecule has 6 sticks and 8 dots, so it has 12 plus 8 valence electrons, so 20 total. This has one more than what we're looking for, so we're also going to cross out molecule B. For molecule C, it has 4 sticks and 10 dots, a total of 18 valence electrons, also not 19. So we're going to cross that out, and the correct answer is D. None of these molecules have 19 valence electrons, and this actually shouldn't come as a surprise because an odd number of valence electrons would require an odd number of dots, which means we would have an unpaired electron, and that's very unstable. Here's what I mean by this. Let's take one of the molecules we dealt with and break it down into its sticks and dots. 10 dots contribute 10 valence electrons, and 4 sticks contribute 8. So again, it's 18 in total. To make that 19 and thus odd, we must add a single dot, which would therefore be an unpaired electron, an unstable configuration. But hold on a sec, if adding a dot to get to 19 electrons, an odd number, is destabilizing to the molecule, why can't we just add a stick instead? Well, we can't do that because we would skip over 19 valence electrons and get to 20. That's because, again, an individual stick represents 2 valence electrons and we can't contribute half of a stick. Mathematically speaking, whenever we add 2 numbers together, the only way to get an odd number is to add one of each, an even and an odd number. And believe it or not, both of these scenarios are even plus even, because although we have an odd number of sticks, each stick represents 2 valence electrons, an even number. For that reason, we cannot have the odd plus odd equals even scenario, because whether we have 1 stick, 7 sticks, 10 sticks, etc., multiplying that by 2 will always mean that the sticks contribute an even number of electrons. And by extension, that would mean that the only way to get an odd total for the number of valence electrons, such as 19 for a molecule, would depend entirely on our dots being odd. So that would mean that we have an unpaired electron. And because unpaired electrons tend to be very unstable, it's rare to have a molecule with an odd number of electrons.